Alright boys, it is time for a somewhat selfish video, I'm not gonna lie. But in the previous video, I did say that I do need to look at the materials for my courses for Berkeley, just to make sure I don't get completely trolled. Basically, Berkeley assigns a dude to help you with class selection, right? And that person emailed me and she's like, this stuff is way too hard, you should not be taking 4 technical classes, blah blah blah. And I'm like, bruh, god dang it, I thought this was only a high school thing they do. But I basically told her that I do know a lot of the stuff already, so I should be okay, and then she was like, okay, it's fine. But let's just see if that's true, okay? Hello everybody, I'm Kara, and today basically all we're going to be doing is we're going to be going through some of the finals of the classes that I'm taking. Either this is going to be very, very impressive, or this is going to be very, very sad, and I'm going to get wrecked. So we'll see how it goes. But before we get into the video, if you enjoyed the content, please like and subscribe. It helps me out a ton, and join the Discord because we recently got to like 2,000 members. It's very cool, and it would be even better if you could join the membership. It would be cool. We talk about all the Olympiad stuff, academic stuff, whatever the heck you guys want to talk about. Alright, so basically the way we're going to do this is we're going to start with the classes I think I'm the most familiar with, and then go to the classes that I think I'm the least familiar with. And the first one is obviously CS70, Discrete Math and Probability. I better know this stuff, otherwise I'm going to be so sad. So why don't we look at an old final. Okay, let's do this. Summer 2019. So I'm just gonna do a couple. Like these midterms are massive, dude. Look at this nonsense. So I'll do a couple, and then we'll just see how hard it is and that kind of stuff. Alright, so let us start with true and false. So it's basically saying that not P implies Q is the same thing as Q implies P. So if Q implies P, that means whenever Q is true, P is true, right? So if not P means not Q, that basically means that whenever P is not true, that means that Q is also not true, which is not true, right? Like, if Q is true, then P would have to be true. Yeah, so this is right? Because essentially, if P is not true, that means Q also has to be not true. So, true. An irreducible Markov chain with a self-loop must be aperiodic. So, basically what a Markov chain is basically you have, like, these, like, chain, right? And then essentially there's, like, edges between them, and each edge you have, like, some probability of going to, right? So, there's like 2 edges, we could have 1/3 chance of going here, 2/3 chance of going there, and then there's a 1 chance of going there, blah blah, right? So if it has a self loop, right, then it has to be aperiodic. So apparently the periodicity of a Markov chain is just like the GCD of all the cycles in the Markov chain, right? And I guess if there's a cycle of 1, then the GCD is just 1, in which case it's aperiodic, I guess. I honestly forgot the definition, but I'm pretty sure aperiodic means that the periodicity is just 1, so I think it should be true. Alright, B is true. Suppose that for random variables x and y, p of x equals x, y equals y equals p. Okay, so basically this just means that they're independent, right? Like, the probability of both of those things being true is just the same as multiplying the probabilities, which means it's probably independent. And then expected value of x, y is equal to, I mean, I'm pretty sure that should be right? I mean, if they're independent, their expected values should just multiply, so yeah, I think that should be right. So C is also true. This is kind of sketchy. Well, okay, let's just see whether I actually got those right. True, true, and true. Okay, very epic. And yeah, it is, because independence. Alright, nice. So, let us move on to the other types. Is there anything interesting? Short answer. Oh, yes, I love propositional formulas. God dang it. I don't even know what this is. I don't know the notation. God dang it. Okay, I'm assuming it's an or. Yeah, it should be an or. Okay. So, if not A or B, right, and A or C, and we want an equivalent formula that doesn't use the downward one, should be or, so this is and. Okay. So if not A and B, or A or C, or A and C. Okay, so either A is false and B is true, or A is true and C is true. Okay, so basically if A is true, then C has to also be true, right? So A and C, or we can't use or though. Wait, we can't use this. Huh. That's kind of annoying. Huh, this is kind of interesting. I don't know. There's some like De Morgan's Law nonsense that you gotta use, but I forgot. Oh, is it? Let's see. Let's see if we can logic it out. I mean, worst comes to worst, we just do a truth table, but I think we should be able to do this. So A, C are true, or B is true. Yeah, we can use De Morgan's Law. So basically, or. So if you say like A or C, that's the same thing as not A and not C, and then not of that whole thing. Epic voice crack, let's go. Yeah, this basically means not both of them are false. So if we have and, that's the same thing as not of A and not B. Okay. Or not of not A or not C. I think that's fine, right? That's technically right? Okay. Epic De Morgan's Law. God dang it, that's nasty. Alright, yeah, basically they just did the same thing as I did. Very cool. Epic. De Morgan's Law is so boring. You literally learn this in APCS. Okay, let's see if there's anything else interesting over here. What the heck is Berkeley Welch procedure? I have no idea what that is. Yeah, I don't know what this means either. Okay, let's see. Distinct, what's a GF even? Whatever. Or okay, they intersect at k points that all lie on a degree exactly k minus 1 polynomial. Okay. What is the smallest value of dp plus dq? Dang, how do you even do that? Well, essentially you subtract it, right? And then that's where the intersections lie, right? Huh, this must be some like common lemma or something, but I don't know it. Let's see. So you do like p of x minus q of x is equal to 0. And you basically want this to be a degree k minus 1 polynomial, okay? And you want the smallest possible value of these things. So, well yeah, why can't you just have like two parabolas and then they just lie on a line, right? Intersect of 2 points as a first degree polynomial. So I guess 4? Could you also have like a line like that? I mean, yeah, this works too, right? 2 and 1. A 0th degree polynomial work? Oh, huh. I mean, yeah. If you have 2 and 1, couldn't it even be like 1 and 1? You just have two linear things and they intersect at one point and then you have a 0th degree polynomial through there. Am I trolling? I don't know. Okay, I feel like it should just be 2, right? Unless I'm overthinking it. Oh, you're supposed to, okay, hold up. You're supposed to put it in terms of k, alright. So why can't they just both be degree k? Yeah, because if you have like 2 points, right? Isn't that just 2k? Oh, but you could also have like, yeah, so if you want to have 2, you could have like that, and then basically you have 1 is k, 1 is k minus 1 for a sum of 2k minus 1, which I think was the answer. Very nice, alright. Yeah, okay, because otherwise they would literally they would have to intersect at all the roots, which doesn't make sense, I guess. Okay, makes sense. What else do we got? Modular arithmetic. Okay, this should not be too hard. 3 to the 13 mod 13. Okay, well, you basically know that 3 to the 13 mod 13 is just congruent to 3 by Fermat's a little theorem. Okay, Fermat. Fermat's, okay, very nice. And then we could do, let's see if there's anything interesting. 70 to the p is congruent to 1 mod p. Isn't that just not possible? Because wouldn't it always be 70? Oh, so basically you just want the 70 to be congruent to 1 mod p then, right? This is just Fermat's little theorem again. And essentially you could do 69 is unfortunately not a prime, sad, but it has to be prime divided of 69, I guess. So you get like 2 or 3 and 23. Okay, is that right? Yeah, should it be 3 and 23? Hey, very nice. Okay, what else we got here? Oh, this would be a fun one. Okay, so I'm assuming this is like a stars and bars thing, and they do give a hint to introduce fourth variable, right? So essentially you have 3 bars, right? And you have 30 stars. That I'm not going to draw 30 stars. And then it's essentially just going to be 33 choose 3. And basically everything in the first 3 are going to be x, y, and z. And then the fourth box is going to be w, and it doesn't count towards anything. Alright, so that should be, is that right? Non-negative, yeah. So 33 choose 3 should be your answer. Hey, very nice. What else we got? A random variable expected value of x is equal to 10, alright. And x is always at least negative 3. Non-trivial upper bound. Okay, let's see if we can do this. Negative 3, and essentially you want the average of all values to x is always at least negative 3. Essentially, what expected value is the weighted sum of all the stuff, right? So essentially, if you want an expected value of 10, well, okay, so essentially we could concentrate a bunch of mass over here, and then concentrate some mass at the 20, right? And essentially we want that to average out to 10. Okay, the more mass we concentrate here, so if we concentrate more mass here, then we could concentrate more mass here, right? If we spread it out over here, then it's worse. So essentially we just want like negative 3 times some mass, right? Plus 20 times 1 minus k is equal to 10. And then if we solve this, we should get our answer. Negative 23 plus 20, 23k plus 20 is equal to 10. And essentially we get 10 over 23 is our answer. Wait, that's not over here, so that means our answer for this side should be 13 over 23. Is that right? Hey, very epic. Dude, okay, this is not too bad. Let's see if there's anything else that's too fancy for us. Oh, okay, yeah, so this is all expected value, nothing too fancy. Yeah, this is all this probability stuff. Okay, I think we're chilling for CS70. Let us move on to the next one. So the next one I'm taking is Introduction to Computer Programming for Scientists and Engineers. Very fun. Bruh. Dude, this is literally ABCS again, and literally I took CS 61A, which is also an introductory computer science course, but apparently that doesn't count for the engineering one, and I want to do a mechie double major, so I have to take this one too. Hooray, let's go. Bruh. So this should be fun. Alright, let us find some finals for that. E7 finals Berkeley. Okay, why don't we go with spring 2017, why not? Okay, so I guess we're just becoming a compiler. Let's go. Okay, basically CS61A, you become a Python compiler. I guess this one is just becoming a MATLAB compiler. Let's go. Okay, so x equals 5, val is 2. This is how you do squares in MATLAB, I'm pretty sure. So 25 minus 6 minus 4, that is 15. I know how to math. Let's go. 1C. What about this one? What will the value of the variable val be after executing the following code? So 0 for val equals 1 to 5. Okay. So if val is 3 or val is 5, you continue. Otherwise, val is equal to val times val. What? I don't know how scope works in this thing. Okay, so I'm assuming every time it gets back to the top of the loop, it sets itself to one of the stuff in the list, right? So, on the last time, it'll set itself to 5, it'll continue, and it'll go to the end. So it should just be 5, 9 is C. My plus or minus, what the heck? Okay, let's see. Result is 0, 4, counter is equal to 1 to value 1. Okay, so going to that one. And then, okay, so the 2, okay. Okay, so essentially you're taking the result is just taking the sum of like 1 to j, right? If we have like a, I, j, saying sum of 1 to j. Okay, so it does this, it sums 1 to j like I times, so I times j plus 1 over 2. And then it subtracts out I times I plus 1 over 2, and that's what we should get. So I is 2 times 4 times 5 over 2 minus 2 times 3 over 2 is equal to 20 minus 3 is 17. So we get 10C. Why is everything C? God dang it. Bro, this is so suspicious. Alright, 11. What will be the value of the variable result after executing the following code? Vector 1, okay, vector is 0, so it's like 2 by 2, I'm assuming. Okay, what are the two? 0 is 2 comma 2. Okay, I know that like MATLAB, basically, if the vector is not big enough, it resizes the vector, I'm pretty sure, to fit it. Does it unroll it automatically? This is so troll. God dang it, I don't know. I'm pretty sure it'll throw error for E, right? Oh, I think it'll actually work. It'll straight up work, I feel like. Yeah, I feel like it'll actually work, so it should just be B then. So let's check those. 1 is C, 9 is C, 10 is C, 11 is E. What? Okay, I don't know what MATLAB errors there are, okay? Okay, so I guess that's what we're learning in the first semester at Berkeley. Let's go. What type of errors are we gonna find in MATLAB? Let's go, bruh. Yeah, well, how about this one? 27. Consider the following function which implements the bisection root finding method. Okay. I don't know what that is, but hopefully we'll figure it out. This function is missing code. Which of the following pieces of code can be used in the two locations to properly finish implementing this function? Okay. Okay, so I basically tried to find it in the left and right of each thing, right? So it looks in the middle, and then if absolute of f of root. So root is, okay, greater than tolerance. Okay, yeah, so basically it's saying that if the left side and the root current thing, like it's like this, right? And maybe this is here. If it's saying that if they're on opposite sides, right, it's less if the product is less than 0, then the root must be somewhere in between here, right? So in that case, you want right to equal root, right? And then you want left to equal root if in the other case. So E is correct, I think. Let us check. 27 is E. Very nice. Okay, so I guess this one's just an ABCS class. I don't think it should be too hard. I am not worried about this boy. Alright, nice. So far so good. But I think we're getting to the harder stuff now. EE16A and EE16B I have very little experience with, so that should be interesting. So basically EE16A is designing information devices and systems, and I looked at it briefly, and it's basically just like circuits and that kind of stuff, so we gotta do some physics. Let's go. Let us try this final. Spring 2015. Bro, why is it so long? Holy. Okay. So we have our explore mode, and we have our analyze mode. It could be one, depending on which mode it is in, 20% of them will detect an interesting, okay, so there's a 20% chance here, and there's an 80% chance they go back here, okay. And then, yeah, okay, and then essentially 50% go here, and 50% go back here. Is that how you draw it? I don't know how they want it, but that's what I think it should be. Hey, very nice. So yeah, you got your 80%, goes back to itself, 20%, yeah, okay. Nice. Now let us set up a vector, okay, fun. Oh, okay, so this should be not too bad, right? X analyze, or X explore, X analyze, and essentially you want your resulting vector to be X explore times 0.8 plus X analyze times 0.5, and same thing for the bottom one basically, except it is X explore 0.2 plus X analyze 0.5. Okay, so I kind of forgot how matrix multiplication works, but essentially we want to multiply it in front, right? So essentially you want, okay, so if this is like a 2 by 2, right, and this is a 2 by 1, then essentially your resulting thing is a 2 by 1. It could also be a 2 by 3. So essentially what we want to do is we multiply the columns by the rows. Okay, I mean sorry, the rows by the columns, and then you add them up. Okay, yeah, that makes sense. So essentially what we get is in our first row we want to multiply by 0.8 and 0.5, and then in our second row we just want our 0.2, 0.5, and we should be good. 8 points now. Let's see if we can do this. With the parameters given in part A, will this algorithm result in a steady state? What does steady state mean though? I guess there's a point where the explore and analyze modes are not changing no matter what. Okay, so I guess we could just write some equations. So we could say this is equal to x explore, and this is equal to x analyze. And essentially, if we solve this, we get x analyze is equal to 0.2 over 0.5, and this one is x explore, and we get the same equation from the top one, which means that there should be a steady state, in which case we could solve this. Well, okay, we know that it's like 1 minus that, right? So what's 0.2 over 0.5? 0.4 minus 0.4 x analyze. So you get x analyze is equal to 0.4 over 1.4, and that gives you 2 over 7, which is, I don't know that, 142.5 wait, what, 142.8572857 okay, something like that, 0.28 or 229, something like that. Okay, 2.5 or 3.5, why would you put it in that? Okay, yeah, so it's 2 sevenths and 5 sevenths, so that is right. Very good. Okay, anything else interesting? I don't feel like doing the bonus. It's only 6 points, so it's probably not too complicated. um Bruh, this is just a bunch of linear algebra. Are there any, where's the, okay, I guess we have some circuit stuff, but I don't feel like doing circuit stuff. Yeah, I don't know what op amps are. Like, I've heard of them. I've learned it briefly, but I don't know how to like do problems with them anymore. Bro, why is this all just setting up matrix equations, dude? Plot this data, very fun, bruh. Okay, this doesn't seem too bad. I think linear algebra is doable in general. Okay, so in many of our devices, we would like to have a means of measuring temperature electrically. Okay, for example, it is often desirable to have devices shut themselves off. Okay, alright, if all the dimensions of the metal pieces depend on absolute temperature like that, and the resistivity, is that, then we want to be E1 and E2. Oh, okay, so, essentially, the only thing that's changing is our length, so our width and height stay the same, and our new resistivity is P of T is equal to, well, okay, that's just our resistivity, I guess we don't need to change that. 1 plus KRT. Our new volume, I guess, L 0 times 1 plus KDT. And then how do you get, what is resistivity again? Like, it is like, bro, this is kind of sad. I should know that this is physics. Bro, I mean, the formula is like rho L over A. Because as you increase the length, your resistivity increases. Oh, okay, so yeah, so it should just be like rho 0 L 0 over rho 0 L 0 and then like 1 plus KRT over your your width and height also increase, so it'll be, okay, so this just goes to the bottom, so with 0 and 1 plus KDT. Okay, nice. Is that right? I think that should be right. Hey, let's go, we did it. We know our physics. Let's go. Assuming that the dimensions of the metals change as in part A, center to center spacing S and permittivity do not change. Okay. Capacitance, bruh. I am not sure. Let's see. E1 to E3, so over here. I do not know how to calculate capacitance for that. Is it just not, okay, so I know it's like E, what is it? EA over D? Um, yeah, okay, I think that's right. So our A is going to be like that way, right? Height times L, so L H0 L0, and then times like whatever, and then divided by S minus W times that thing. So 1 plus KDT squared, and then 1 plus KDT. Okay, is that right? Let us check. I think that should be right. Hey, let's go. Nice. So I guess we do know the physics stuff. I mean, maybe there's some stuff we don't know. Yeah, I probably don't know how to do this one, but there is some fun stuff here. Okay. Yeah, I don't think there's anything too fancy. A lot of this seems like math, right? And then I guess there's some like concepts I don't know, but should be not too bad. Okay. All right, on to the last one. We got EECS 16B, which is basically the same thing as 16A except more complicated. And this one, I'm pretty sure I have no idea how to do any of the problems whatsoever. So let us see. Okay, so I guess they gave it on Canvas. Very interesting. Well, that would make sense because everything's online. But let us see. Consider the following continuous time system. I have no idea what that means. I mean, this seems not. This seems kind of complicated. Let's see. I don't know what's stable and overdamped. I don't know how to get stable and overdamped. Yeah, I don't know any of the equations for this nonsense, so we're gonna skip that. Okay. I think this is true because capacitors only become like a closed circuit when, or an open circuit when, wait, no, what? High frequencies mean it's never gonna be charged, right? I'm pretty sure that's not true. Like, it would act as a short circuit, not an open circuit. Open circuit basically means like infinite capacitance, right? I mean, like infinite resistance, and then short circuit means that it's zero resistance. And a capacitor is only resistant if you have like charge buildup, right? Yeah, so basically for an inductor, its resistance basically decreases over time. So essentially, if its direct current is not changing back and forth, it should just be a short circuit after a bit of time. So 2 should be right. The voltage across the current source remains constant. No, the voltage could be whatever. The only thing that stays the same is current, okay? And resistance can be determined from the device's current voltage characteristic. I don't know what a voltage characteristic is, but I mean, 2 and 4 is the only one that satisfies the rest of the stuff that it came up with, so maybe that's what it is. Let us see. Hey, let's go! We know physics. Epic. Which of the following could be the singular value of that? I don't know what singular. What? I don't know what these terms mean, so we're just gonna skip that. Very epic. Bruh, these. I have no idea what any of this stuff means. Okay. Eigenvalues. Okay, do I know what eigenvalues is? J is basically the same thing as I, like root -1, so we should be able to compute it. The magnitude of the top part is just going to be omega RC, and then the magnitude of the bottom part is a complex number, so it's going to be root of 1 plus omega squared R squared C squared. And if we plug in 1 over 2 RC, that should just be 1 over 4, so it'll give you like 1 over 2. So 1 over 2 over root 5 over 4, right? And then that basically gives you 1 over root 5, which is right. Okay. I'm pretty sure because the numerator and the denominator have the same angle, so it shouldn't be 90, so that's fine. So I guess the only one, yeah, so B should just be wrong. Question 7 is B. Hey, let's go. Dang, this is not even that bad. Alright. Dang, okay, well this seems interesting though, at least. It seems like it's a lot of math though, too. I'm sure there's like some kind of like formula, like there's just some inequality for determining whether it's uncontrollable or stable or damp, but I just did not know it. Okay, you know what? I honestly don't think I can do any more of them. So, let us just call it a day. Well, those are the 4 classes that I'm taking at Berkeley. I'm probably going to take 1 humanities course, so I'm not going to go do the final of that, because humanities, no, we're not talking about that. But anyways, I hope it was enjoyable. I hope it was fun looking at what we're going to learn next year at Berkeley. Maybe I'll even make some videos from when I'm actually doing the class. That might be fun. But anyways, as always, if you enjoyed the video, leave a like and subscribe for more. Let me know what other kind of videos you guys want in the comments. I need some more ideas, please. Let me know. Other than that, we are done for today, so thank you guys for watching again, and see you guys next time.